All right, we're moving right into our next video, which we're talking about histogram charts now. We mentioned these a little bit when we talked about bar plots. They're pretty similar, but we want to make sure that we know how to understand how a histogram is created, be able to interpret the information which is displayed in a histogram, and describe some of the attributes of a data set that are based on that histogram. So if we look at this data set, right, we've just got this data set C. I can't remember if this is a real data set or if it's something that I made up. But you know, we're going to have a histogram for it. But before we jump in that, right, let's say, like, what is a histogram, right? It's a chart which shows frequencies. Almost always on the y-axis are you going to see frequencies. Sometimes you'll see proportion or probability, but typically frequencies when we're talking about histograms. And we're talking about intervals of continuous numeric values, right? A lot of times say people will say, oh, we put things into buckets or into bins, and we see how big those bins are, right? How many items are in each bucket, each bin? What is the frequency of values in each bucket or each bin, right? So we have this data set. Let me zoom out just a little bit so we can look at the plot all in one. I don't remember if this is a real data set or I made it up. That's not particularly important. What we're looking at is this data set, this numeric data set that we have here, C, expressed as a histogram, right? As we mentioned, on the y-axis, we're dealing with frequency. We're saying how many occurrences in this range were there. And then we have the x-axis broken up into buckets, right? For example, 82 to 83, 83 to 84, 84 to 85, so on and so forth. As to these buckets, the way they typically work, like someone might say, what about this value, 87.0? Right? That's right on this line. Is that in the bucket on the left or the bucket on the right? Luckily, just like Python, these things have a tendency to be left inclusive, right exclusive, right? So the left or the lower bound is included. So this bin represents 82 all the way up to anything less than 83, right? But 83.0 would actually be in this second bin here, right? So it is the left or lower bound is inclusive, the right or upper bound of a bin or a bar is exclusive. And if you think about the range function or the way that we slice a list in Python, you know, that first number left of the colon is always included. That number, that index to the right of the colon is not included, right? Or that second value in the range function. If I say starting at 0, ending at 10, right, 10 is not included, right? So the same concept here, left inclusive, right exclusive. But we can see generally when we build a histogram of some data set, like we have here for this data set C, we can see how the data is distributed, right? We talked about this a little bit in the 5-number summary, right? That gives us an idea of how spread out the data and where the concentrations of data are. And this does the exact same thing, just a little bit more effectively by breaking down into, looks like we have 8 bins on this chart. So where we have 8 bins on this chart, right, I can see, hey, that my mean or my most common value is likely to be in this 84 to 86 region, right? And that's where most of the values are. And then I sort of have some tails, right? I would say this is kind of approximately normal shaped, right? Or like a bell-shaped curve. We can't say it's exactly that way, but we can sort of see that, hey, it's kind of in that ballpark, right? This gives me an idea of how my data is distributed. You'll often hear us refer to a data set as a distribution, right? And this is sort of what we're talking about, you know, how these values are distributed across the range of possible values or measurements that were taken. It looks like right? This talks about our little left inclusive, right? Less than or equal to 82, but strictly less than 83. Left inclusive, right exclusive, like we talked about. And that's the basics of how you can read a pie chart, right? On the y-axis, we have frequencies, right? So I could say I had 5 values that were greater than or equal to 84 and strictly less than 85, right? 4 between 85 and 86, so on and so forth, right? I can sort of have an idea of the distribution of this data. Now, when we start to look at that distribution of the data, it can tell us a little bit more about it, and that is we can use our histogram to identify skewness. In this case, we have 3 data sets that sort of display the different kinds of skewness. We have one symmetric data set, we have some left skewed data, and some right skewed data. Now, when we're talking about left skewed or right skewed data, you might also hear these referred to as negative skew or positive skew. And luckily, there's sort of an easy way, or it's become easier for me to remember, which is which. Now, when I look at this left skewed data, I see that it is sort of spread out over on the left side here, right? And it's got a longer left tail, which is pointing in the left direction. So it's pointing in the left direction. That tells me, hey, this is a left skewed distribution of data, right? The tail points left, it's left skewed. Also, the tail points in the negative direction, so you could say that this is negatively skewed. Now, the opposite is true with the right skewed data. Here I have a longer tail that points off to the right, and doing so, pointing off to the right, it points to the positive side. So I could say that it is either right skewed or positively skewed. Now, if we think about what does it mean for a data set to be left skewed or negatively skewed, right? And if we think about this, we have frequency on our axis here, our y-axis. We have a range of values between 0 and 1 for each of these plots. What we're saying is that on the left side, there are more outliers, right? There are more negative outliers, right? In general, most of the data is centered between 0.6 and 1, but I do have some low outliers, right? Values between 0 and 0.2. It looks like down here on the very left side of the plot, right? So this is telling me that my data is not symmetrical. I do have some outliers that are non-symmetrical. So if I was maybe trying to talk about an average or some sort of measure of center here, that might inform me, hey, I'm going to stick with median instead of mean in this particular case, because this is left. This data is skewed, and I know that it has outliers, right? The same thing is true for right skewed data. When you have symmetrical data, that's more likely going to be an indication, hey, it's probably okay to use the mean here. So that's going to be your best bet. We can also use histograms to visualize modality. When we talked about mode, we talked about some data which might have more than one mode. That would be bimodal data, or multiple modes, multimodal data. There isn't just like data with a single mode in this plot, but that's, this is one mode here. There's only one sort of bucket with a high frequency. There's only one peak to the distribution, right? And the same is true on this very first histogram we looked at. Right, we can identify how many modes there are, right? So if we are looking at average weights of household pets, right, I can see, there's a concentration down here, maybe around 10 to 13 pounds, and then there's another concentration up here between 20 and 27 pounds, right? This lower concentration maybe being cats, and the upper concentration maybe being dogs, right? And also it's important to, when you're building a histogram, to be careful with how many bins you choose, right, when you build a histogram. And this is just showing an example where you can sort of skew data to make it look different than it actually is by using the wrong number of bins. This is actually the same data set, just with different numbers of bins placed at different intervals, right? This makes it seem like, oh, all the data is lumped up really close to each other. It's pretty uniform in its nature, but we can actually see up here, if we break down to some smaller bins, we can see that's not true of the data at all, right? There are actually 3 separate sort of concentrations of data in this distribution. So a great place to start when you're thinking about number of bins is just the square root of the number of samples that you might have, right? But that's just a real brief preview into actually making histograms, a lot of which we're not going to do at this point in the course, but you will do a little bit later on. So that's about it for our histogram lesson. A really important data visualization that you're going to use ubiquitously as a data scientist or a statistician, typically to express data sets like we have here with this sort of histogram of C. We want to use it to identify whether or not data is symmetrical, as well as the skewness of data. We can actually just read the charts and sort of see where the concentrations are. We can see what the mode might be, what the mean might be, and things of that nature when we are looking at a histogram. So that's it for this video. In the next video, we're going to talk about scatter plots. Again, probably something that you're pretty familiar with. So I appreciate your time and look forward to seeing you over in the next one.